instructions sitting around. We might have, I might have to be, this, I can't make it do anything. So. It's crazy. Am I logged in? Yeah, I'm logged in. Okay. Full client with video. Maybe that's what it is. I don't know. Use microphone. No. Lock. Use camera. No. Complete. Here we are. Here they are. Yeah. I blocked audio. I blocked the camera and the mic. Okay. Okay. I don't need that. Okay. So now we need. That's so weird. It doesn't show up here. Okay. So has anybody else chaired a meeting yet? Does the thing on, does your laptop on the right actually work to do anything? No. Yeah, you got to use your own. Okay. Well, that's new. I'll let you present. I'll let you present this, but let me make sure I can control it. Oh, did you want to control it? All right. Well, welcome to the LSR working group at IETF115. There's a note well. Please note well. A lot to read there, so. You gonna? Yeah, I'll read that. Are you gonna rock star it?
Yeah, I am.
Okay.
I stand up.
There's a stand mic right there.
Good morning, everybody. You can all hear me, right? Before we get on, I'd like to recognize my former working group chair is with us after a long time, Avi Roy. And with that, I'm going to get right into the working group status. We had a really productive space of time between 14 and 15. Got all these Yang models.
Sorry.
Ying Zhen's going to cover them in her presentation. Next slide. Now here we got all these drafts. Not only John did a lot of work, excellent work. I mean, it was it was getting all these, and Ketan and Peter and Dhruv and even the Viz document, there was some that Les did. We got all these not only through the AD review, but through all the directorate reviews and through the ISG, and they're on the RFCQ. This is significant. The flex algorithms, that's the basis for a lot of the working group drafts we got today. Next slide. We still have this, but once flex algorithm is, I guess it'll be published as a cluster. I probably should have updated this because flex algorithm is now in the RFCQ. Next slide. And we got the flood reflection. John and Peter actually got through the AD review on that. The directorate reviews, that's going to be in the telechat early next month. The OSPF extensions to SRV6 correspond to the ISIS ones. There's some, we went through a few iterations of that. And we just finished the OSPF terminology, has publication requested. It does no longer need a routing directorate review. Sue Harris did that, and it's ready for AD review as well. Next slide. Let's see, we got this one. We covered this on the list. This is the one where I'm talking to some of the implementers, OSPF v3, to make sure that the 24-bit metric, it's all right to use that to make the base a prefix unreachable in the base topology for intra-area routes. Currently, it's used for inter and external routes, but we want to extend that. This will really be useful. It'll be just the same for all the route types. Next slide. We're going to cover all these Yang documents in Yang Zhen's presentation. Next slide. Fast flooding, I think we're pretty much there. That draft generated a lot of interest, and we've had some implementations. It's not something that you have to standardize what you do internally, but we've gotten Bruno did some good work on the signaling to signal just the right amount of information between neighbors so that the flooding can adjust to the conditions of the router receiving them. And I don't know if you followed it. We have these two that Wes is doing there were some things we couldn't fix in erratica in the application-specific metrics for ISIS and OSPF. So Les started the ball, and Peter's doing the other one, and we're fixing them. We got some other. While we were doing it, we're not making any big changes, but there were some other places that needed clarifications in those drafts too. So we're doing those too. I think they could probably go pretty quickly. Just a matter of, I want to read them once over and encourage everybody to read those too. Next slide. Oh, this is more Yang documents Yang Zhen's going to cover. Next slide. And I'll say the OSPF generalized transport, that's been renamed. I'm gonna have you're gonna get to hear me talk again today, so let's cover that. Next slide. I don't think I need to say anything about any of these other ones. The extended hierarchy, that was a lot of good work, but we thought that it was enough of a significant change to ISIS. We'd really want to let it park until somebody implemented it. And the main offer, Tony Lee, has said that there's no the impetus to implement it has gone away, and so I think he agreed with me that we should just wait on this one until somebody implements it. If you know, right now ISIS of course has level 1, level 2. This would extend it n levels. I forget what it was, 16 or something. And I think that's the only one I want to talk about on this slide. Last slide. Okay. I know we have some documents that people are wanting working group class calls on. I didn't cover those, but please remind us on the lists or send us, I know we have some, at least a couple adoption call requests from offers of other drafts. That's it.
All right. I have an agenda.
We have Yingzhen.
Yeah, that's the Yang documents, right? So I'll present. Do you know that was there?
This one.
I said, do you know there was a mic there? No, there's a mic. That's it. Oh yeah,
I like this one.
you like the rock star.
Yeah.
I like the rock star too. Sure. All right. Looks like it's up.
Um, Good morning, everyone. This is Yingzhen. I'm going to do an update of the SSR Young models. So I'm now going to bore you with all the model details. So this one is mainly a roadmap of all the LSR Young models. So next slide, please. Okay, so we finally published the ISS and OSPF based model. Also RxC 9134, the young model for ISS reverse metric. So last time I did a young update was at the IETF in Singapore 3 years ago. That's the time when we were happy the both base models were in the RFC editor queue. So 3 years later, we made it. It finally published. And so with those two base model published, and that made all the protocol extension modules augmenting those two base models, the publication possible. Slide, please. So the next few models we want to publish, like the both OSPF and the ISS SRM module. So these two were pretty much ready, and the ISS SRM model actually already finished the young doctor last call review, and we need to do the same thing for OSPF SRM. And the OSPF V3 SRM. So all these three are for MPRS data plane, and that one we actually sort of forgot it. We need to do the working group adoption call because we were waiting for the base model anyway, so we didn't hurry. And that one we probably need to speed up a little bit. And so this will publish the I try to publish the ISS and OSPF SR first.
Yingzhen, can I ask a question?
Sure.
It took us 3 years. Do you think that was our fault? Like, just do a little debrief here. Was that our fault or the process, or what do you think?
Well,
You can say it's our fault.
well, we were waiting for the BFD module to publish because we have a dependency on the BFD module. Jeff has it there. And so after the BFD module published, we found some problems, and the BFD module had to do a biz version. So 3 years later, we are here.
Okay. So
Yeah.
I just wanted to make sure if we did something bad, we could fix it.
Yeah, we were waiting.
As Murphy's Law would have it, there's actually somebody during the last 3-4 months that is working on an open source implementation of the OSPF Yang model, the standard one, not the OpenKit, the standard one. And so we got a lot of late comments from him. I think once he's not ready yet, but we're going to ask him to come in and present his open source code if we, on the agenda at a future IETF. I think that'd be good. Can't remember his name right now. It was the guy from Brazil.
Jeff has a very quick comment just for the notes. So absolutely correct. BFD did hold things up because we found a bug. What was sort of the interesting bit of the process is that we found out that for effectively 4 lines of fix an IETF, it could be 8 months to get it through as a Yang module update. And as much as it was our fault, as you're saying, you had all these last minute things that crept in after last call during our RFC process. If every one of those things you had ended up needing to be individual update, the 8-month timer would have basically restarted. So we need to find a way to sort of make the entire process faster, because if you're in open config land, you hold a meeting, it's done.
Yeah, that's exactly why I'm asking, right? Is because if we want to be the standard instead of open config, we got to find a way to be able to publish these faster.
Exactly.
Yeah, so for the OSPF based model from the first version, the 00 version individual draft to the end, it's publish at the RFC just took 9 years.
Wow.
Yeah, I just want to say one more thing about these two models, the SR models. Once we publish these are the last working group documents from before the merge of the OSPF and ISIS working groups. So it'll be good to publish these as well, because then you'll be able to do a search in the data tracker for -LSR- and get all the working group documents, or all the and all the drafts that people are submitting.
Next slide, please. Okay, this one we also want to get it published soon, because this is the OSPF v3 extended LSA. It also lays the foundation of all of some of new feature extensions based on OSPF v3 extended LSA. So we need the working group chair to start the young doctor, request the young doctor review and routing direct review, same as the previous two. Next slide, please. Okay, OSPF admin text. This is the experimental draft we are doing, not experimental compared with standards RFC-wise, but this is the one we try to put the young module inside the draft itself. We choose this one because this one is very, the protocol extension itself is very clear and straightforward. And we just thought we may want to try this. But for some features that's more complicated, like a flexible or application specific attribute, that's probably we want to keep the module separate. But this sort of extensions are, we think, are the candidates we can try.
Yeah, I'm a really big fan of this type of thing. I think I was kind of in the rough though, like I couldn't get everyone to sign along with it, but just my experience of even running them in dual documents, nobody actually pays attention to the Yang document anyway, right? Like when I've run it in two, they just follow the base document. It doesn't, I just don't think it holds anything up to put it in there. Unless you don't have the person who knows how to do it. That was the big complaint when we brought this up the first time, was the person doing the protocol extension work didn't understand Yang well enough, and they didn't want to have to be required to do the work to get their protocol extension. But
yeah, and the OSPF and ISIS Yang models are quite involved. After a number of people, if we have like examples like this, it'll make it a lot easier to do. Whereas, to get all those XPaths right and everything and constraints right.
Agreed. That's a good point.
Yeah, so if you have a draft that's small protocol extensions, you want to have this sort of draft, have the YAML model put together, and you don't want to write the YAML module yourself, just talk to us, any of us will try to help.
Yeah, definitely. I think we could find experts that could help you.
Next slide, please. Then we have the OSPF module augmentation for additional features version 1, and we have the same thing for ISS. So these are the modules that didn't make together with the draft, so we have them put all together. So we just keep adding different new features. I think after we publish the SR module and the extended LSA module, then this will be the next batch, both the OSPF and the ISS. So we'll cut a stop there and then start our version 2. So this is the list of features so far we cover. If you think we missed something, just let us know. Next slide, please. Yeah, this is the same thing for ISS. That's the list of features covered in the ISS module. Next slide, please. And then we have the OSPF and ISS SR Yang module. These are just sitting in the back burner for now. Will be after the base draft published, we'll look at this one. Next slide, please. So just a summary, you can see the different colors. They mean different, probably go as batches, how we want to progress them. And next slide. That's it. Any question, comment, suggestions?
Yeah, I actually don't, I don't know, does the extension cover all the published RFCs, or do we still have more to?
We'd have to do a gap analysis.
Yeah, okay,
Yeah, I couldn't say that it
for sure.
does.
You mean the augmentation version one?
Yeah.
At the time we wrote it, we went over the list of all the published RFCs, and we think we try to cover that has some deployment. We did skip some of the not very popular
Yeah,
RFCs.
okay.
So,
We also have some that we haven't done that are in other working groups, like beer. We have beer. There's some extensions in beer for OSPF, and
I think they have their modules in their working group.
they have augmented ours.
I need to check.
Yeah, I don't think they've augmented the IGPs, but I know they have
Like
their
the
own.
OSPF
They have
beer.
their own standalone beer model.
Okay, yeah, I'll take a look. If they don't have it, then we can write one.
I mean, because I kind of think I'd like to get, I know you guys like the chunking, but it sure would be nice to just get the people that are proposing new things to do it. So that we don't have, because like you said, the problem is you keep adding things to it, right? And as Jeff said, that resets the timer.
Yeah, so this were like some of the RFCs were published before we started Young Work. So it's sort of like a catch up.
Right, exactly.
Yeah.
So this made sense, right? But I'm saying, like you said, you're going to start version 2 after this, and I'm like, why can't we just? I really wish we could just publish them along with the work.
Just like I said, some feature like admin text, that's very straightforward. The draft itself is not very very controversial, or people have a lot of discussions. So the model is also straightforward. Like flex algo, you probably want to separate instead of put them together.
And we did.
I don't know. That's just my thinking.
I mean, but the thing, nobody's going to complain about the Yang model, I guess, right? They might complain about the product, but the operational state describing it, I don't think is going to cause any. It's just I'm just trying to figure out a way to get this stuff to go faster, right?
Yeah.
I mean,
also because the base model published now it's possible
Yeah,
to publish those
absolutely.
things. Otherwise, before it has the dependency, so we don't want to block the publication of any draft because of a Young module. So now it's possible.
We also skipped the experimentals, especially the ones that haven't taken off.
Right. Yeah.
Like there were 3 different Manets, and I know one of them has very limited deployment, but the other 2, I don't believe they're deployed. And so actually those would have added significant augmentations, would have been a lot of work. There were some other experimental ones we skipped. We didn't do ISIS, TTZ, anything experimental we skipped as well.
That's it. Thank you.
I mean, OSPF.
yeah, it's okay. All right, what's up next? Thanks, Yingzhen.
I guess I'm up again.
Yeah, I believe that you're up on the.
Okay, this is the OSPF generalized transport. Now, the most work we did on this was coming up with a new name. It used to be transport instance, but we decided that it didn't really give it the gravitas that it required. So we came up with this new name, the OSPF GT. Grand Touring, no, generalized transport. Next slide. Right. As you know, we have a lot of drafts. I'm going to go into this that use OSPF to distribute information. So this is really using OSPF is very and ISIS as well has proved very useful for disseminating information throughout the IGP domains, OSPF domain, and in ISIS. They have a RFC, I forget the number of it, called GenApp, where you can have another instance. Well, for OSPF, OSPF is actually better suited for this dissemination of information throughout a domain than ISIS does, because it runs on the IP layer. So we were able to, because of that, we were able to remove all the restrictions of generalized OSPF because it does not compute hop by hop routing. Next slide. Now, this is the biggest thing. Besides having a separate instance in which you're gonna flood non-routing information, you can have sparse topologies. What I mean by a sparse topology is that the instance only talks to those OSPF routers that require the information. Also, because we're not computing hop by hop routing, you still have a topology, but it can be an overlay topology. It doesn't have to be an overlay topology, but it can be an overlay topology where you have remote neighbors and you simply establish the adjacency over the unicast topology. Next slide. Here's just an example. You see you have the OSPF routing domain there, and you can see that all the routers inside the domain, they only do unicast routing in the base instance 0. And you have routers on the edge that are maybe doing some sort of services that they need to have some information disseminated to. And they have multiple instances. So you establish the adjacencies across the domain, and you just use normal OSPF flooding mechanisms to exchange the information. One of the main reasons we don't like to use OSPF and ISIS to disseminate information is because a lot of times it's to maybe 1 or 2 other routers in the whole domain that are doing something, and they don't need it, and everybody in the whole domain gets it. Next slide. Well, another thing with this, now a lot of people have said, okay, you can put it in the base OSPF instance, and you can still prioritize the unicast routing information or whatever over any other information you're distributed. That's very hard to do. I mean, we already have all this stuff in here where we throw away hellos, packet processing. We make sure that's done, because if you lose an adjacency, it starts on. The next thing we don't throw away is ACKs, because if you don't get the ACK through, that's the next priority in OSPF. You put it on the retransmission and queue, and it starts. We haven't seen them as much anymore. I think Murphy's Law has helped us a lot, but in the early 2000s, we had a lot of bigger networks that were just getting into melting due to topology changes and flooding. So putting it in a separate instance, especially since most platforms are running and people are running, routing protocols on top of Linux, it's much easier to prioritize a process, to keep things separate. You can use what I was going to say. OSPF v3 supports the instance in the packet directly. We have an extension, an RFC for OSPF. I don't think it's been implemented much, but you can do instances in OSPF v2 as well with using a reserved field in the packet. And like I said, for the packets, you can use different IP precedences, or I forget what it's called in OSPF in IPv6, but you could use the analogy to IP preference in IPv6 to prioritize the unicast packets over the OSPF packets for unicast topology over the ones for transport instance. And here it just shows a new TLV. Basically, ISIS has already gotten a registry for GenApp for the different applications, so we'll use that same registry for any applications, and we're able to, for OSPF v2, we're going to put the have a new OSPF opaque LSA type with a new function code. For OSPF v3, we'll just use a new LSA type. Next slide. And the first, we only have one other new TLV, and that's a top level TLV. So we're figuring with this will identify the application type, and then the applications will specify the encodings underneath this top level TLV. Next slide. Okay, this is talking about applications. Now, we didn't attempt to define the applications themselves in any draft. Let's say this becomes, assuming this becomes a standard at some point, anything that uses it would need to define the adherence to the condition of reachability. In other words, over this sparse topology, you'd normally only be able to use information from a router that was reachable over the sparse topology. And whatever your internal APIs, you'd let people, you'd withdraw it. Now, you could relax that for a given application. So you'd use information for some period of time and sort of smooth things out, even if the connection went away. And here's just some, all these are controversial. Like I said, these aren't covered in the draft. There was a lot of discussion on IDR and LSR about the ongoing effort to keep BGP-LS in line with the IGPs. Now, what this would do, at least for OSPF, you could just put a wrapper around this, and you could just transport the LSAs between routers over the sparse topology without any re-encoding, and then do whatever you want with them. I mean, I know we got a lot invested, a lot of controllers. I don't think this will happen. I think we'll just stay with BLS. That's my thinking. But this is one. Another thing is now we're talking about putting all these flow specs, depending on how much you could put those into this management information. And there's a 5G application in the draft. Okay, next slide. Yeah, we're not asking for, we're not going for working group last call or anything, but just asking for comments and people to read it.
Yeah, Ajun from China Telecom. I think this current format of a document is well written, but the approach for such direction is whether it is good direction or not need to be further discussed. Here is my point. I think the reason we select or you select the OSPF as the delivering protocol is it can provide the reliable and fluid mechanism. But for the non-routine information, we don't need the fluid character. We just need the reliable character of the OSPF protocol. So, and based on this assumption, the reason that we, there are various reliable transport protocol in the current IETF standard. So the reason that we still select the OSPF as the transport protocol, I think it is maybe such information may be related to the routine information. But in your draft, you just omit the interaction of the OSPF routine instance and the application routine instance. I think this is the most important part. If you consider the interaction of these two different kind of OSPF instance, I think the situation will be complex. And there are another point that you just put the complex to the operator. You know, for the different instance, the operator must deploy the different set of the neighbor. Okay, there are a lot of redundant configuration and management for the overall network operation. So I doubt whether this approach is the best approach. And we can see from the history of the another related draft that you have mentioned, the general TLV, and currently there are I think there is no deployment for such a solution. So I think this is the indication for the similar approach is not maybe not the best approach. Okay.
Yeah, the draft, that's one thing I think I need to add to the draft is the manageability considerations, and it definitely will require, more configuration than if we just had a knob to stuff everything into the base instance.
But that could be, that could be the special sauce vendor supply, right?
Exactly. It's how well they do it. Exactly.
Exactly.
Yeah.
There are one of the use case is for the MEC deployment. For MEC deployment, what we want to achieve is the combination of the network information and the server information. So we expect such information be transported within one unique instance, not the different two instances. Okay.
Yeah, that one. I'll have to look at that application. That application. Let's say that I know there was a lot of comments on using that. Maybe that doesn't belong in the transport in OSPF GT, because that would affect routing. That is a routing draft. I'll take a look at that. Exactly what we're talking about for the 5G.
Okay. All right. Thanks, AC. Who's up next? Peter.
Okay, I'm Peter Pshenak. I'm going to present an update on the prefix unreachable draft.
Or lift it up, yeah.
Okay, lift it up a little bit.
Or you can be the rock star, Mike.
Is better? Okay, next slide, please. All right, so this has been presented at the last IETF. I'm not going to do the same presentation. I'm just going to do a quick update here. So what this draft does, it proposes a backward compatible mechanism to advertise unreachable prefixes. This is done for certain purposes. One of them is the BGP peak functionality in the presence of the summarization. So there's no protocol extension here. We are using existing protocol mechanisms to achieve what we want to achieve. Next slide, please. So we updated the draft based on some of the comments that we got. We explicitly specify in the draft which ISIS TLVs are supposed to use the UPA. We did the same for SPF v2 and v3. We specify the LSAs and TLVs where UPA is applicable. We got a comment saying that what we do when we propagate the UPA is not what the base specification of the protocol do. So we put some text in the draft describing that you cannot use the reachability for propagation, which is what is being done in the protocols for the regular reachable prefixes. It's contrary. You must not use the reachability. You basically propagate unreachable when you don't have the prefix reachable. So that is a deviation from the basic specification. We also we got a comment from Bruno, I believe, that we wanted a text that the processing of the UPAs on the edge devices should be optional and configured by the CLI. So we put that text in the draft. Next slide, please. So in terms of the intended status, the draft is published as it is as an informational. Some people feel that because of the propagation specification, we have some normative language there. We should change this into the standard track. I leave that up to the working group to decide. I'm fine both ways, but probably it would make a sense to make it a standard track because of that change. Next slide, please. Yeah, and the biggest discussion that has been going on the list is either using the unreachable metric that is already defined in the protocols versus having an explicit signaling for unreachability. So some people feel we should have an explicit mechanism. Well, the problem with that is that it would make the change non-backward compatible. So to deploy this, you would need to update every single router in the network. Otherwise, the routers would keep thinking that this prefix is actually reachable. So that would significantly complicate the deployment of this extension. I personally don't see any advantage of doing so, given that we have the mechanics in the protocols already. But obviously, this discussion might continue, and I can see it is going to continue. And next slide, please. So we are welcoming any comments and discussion on the working group. It looks like there is sufficient interest in this. There is an implementation, at least one. I know the second one is being done or will be done soon. I would like to ask for the adoption of this draft, and no, I think there's enough interest in solving this problem.
Is the implementation the same vendor, or do you have a multi-vendor?
No, so far I only know about a single implementation.
You said a new one though. Is it?
There will be one which is coming.
Is that?
So that's a different vendor.
Oh, that's great.
Yeah.
Okay, we have people in the queue now. So,
yeah.
Aijin.
Yeah, I'm from Telecom. I think we have discussed this topic intensely on the list and with Peter and other person. Until now, we think the implicit approach is not the right direction. My point are following. First, in the current RFC and the one LSA is encoded with the LS infinity. The router just ignore the received LSA and make the prefix that associated such a metric is not exist in the FIB table. So the detailed specifics will be removed from the FIB, but it doesn't reprint the prefix is unreachable because there may be other summary prefix that cover this detailed prefix. So I think this is the right usage of the LS infinity. And the second point is there are several other usage for this value. So I think we need not complex the situation by reuse or redefine the LS infinity meaning for the prefix unreachable usage. And I think Peter have mentioned for the LS infinity definition in for OSPF v3, and if we done as Peter's expression, I think the situation will be more complex. You know, it will bring more limitation for the deployment of the such solution. You know, I think from the implementation of the one device, it is easy to implement it. But for the deployment of the overall solution for one operator, I think it complex. So we think we should simplify the situation and need the explicit indication for the prefix unreachability. Okay.
Right, so let me try to answer your comment. So the definition of, you are talking mostly about the OSPF LS infinity. I guess that's clear. It's obvious that it means unreachability, whether you like it or not. It is unreachable and we can use it. In terms of using this metric for other purposes, you're probably referring to IP flex algo and things like that. We have defined explicitly that these metrics are infinity metrics in that context as well. So honestly, I don't see any complexity, but we can argue forever. We tried on the list. I let the other people in the working group to speak up.
Yeah, I agree. You guys have been going back and forth, and we should get other people's opinions, and then we're going to have to make a call, right? I mean, we have to let AC, John, Ketan, and Wemo go before you, Tony. Yeah, okay, good.
Okay, speaking as working group member, the first thing I gotta say, I think it needs to be standards tracked because the AVRs need to have a different behavior of propagating it. I think you mentioned that. I don't know if everybody got that. And I really think this is the best from backward compatible standpoint.
I don't think it's picking your voice up.
Is it?
No, hold it back.
Are you? Yeah. Okay. Hopefully they can hear me on the other over the internet. Yeah.
Right.
Okay. So also speaking as a working group member, if there's implementations, I think the one thing that I didn't get way back about a year ago when we started talking about this was this is a temporary, if like an ephemeral notification in this, at least this draft. It's meant to go to routers that are going to redo the recursive resolution. So it's also from a deployment standpoint, it's actually better from a deployment standpoint and manageability standpoint because you only have the routers that need to do it acting on it. That's all I'll say.
That's the comment that we got and included from Bruno.
Okay, John, you're up.
Okay, just speaking as a contributor here. And it just occurred to me because AC presented like just before you or a couple before you, is like, isn't this potentially an application for the Gran Turismo version of OSPF that AC just presented? Because there's like a whole bunch of routers in the, that just don't need to know about this stuff. Thank you.
Yeah, I mean, it's a fair comment, but this is directly related to the routing. I look at it as a routing information, and it is basically related to what we advertise as a routing. So putting this into a different instance would be a bit, messy, I would say.
Yeah, that sort of came up at the end
But you're right in terms of that. Not everybody needs this. So we flood it because this is just flooded as a standard prefix reachability with a specific metric. The processing is up to the receiver, whether it acts on it or not.
Quang Zhao?
Hello, this is Qiang Zhou from Huawei, and I have two comments. Now, first is if we use RS emitter, so we also need to consider the comparison because in the network we deployed some router, but they didn't think they didn't know the new behavior of what you want to do, like the RS emitter. Now new and
it's not new. The act on the
they just
all is new is
want
optional.
to do the unreachability, but the new behavior maybe in the future not do no.
Okay, so are you asking we want to use the LS Infinity for some other purposes?
For currently,
it's unreachable. We can't use it for anything else. We can only use it for unreachable.
Our Huawei and Cisco device have the max metric command. In
but the
our
max metric has a reserved value.
Yeah, this is. But for the new router, for the old router, this command when we use this command, we advertise max metric RSA, and the only use is to define the unreachability. But in your draft, in your document, the behavior is to define, maybe have some new behavior, I think. So if in this situation, I think the old device can't do that.
So if you are referring to the, the interaction between the max metric and this one, they basically do the same thing. If you do a max metric, what you do for prefixes that were reachable, that you advertise,
Yes.
you advertise it with a max metric.
Yes.
So we are making something reachable, unreachable. What we do here is that we are advertising unreachable for something which never was a reachable, because it's part of the summary. But at the end of the day, what you want at the edge device is to act on the loss of the reachability. So I don't see a conflict, but we can talk about it.
Okay, maybe we can discuss more on the merits. Okay.
Sure.
John?
Cisco. So this is mainly about the LS Infinity use. I just want to echo that this has been there in the protocols since decades. There is nothing changed there from its meaning or semantics purposes. Probably what's added is really the processing at the receiver to treat it as an indication. So I really don't understand or follow the debate about the LS infinity part. Yes.
Thanks. Wemo?
I think this is a very interesting hot topic in the LSR.
Speak up a little bit. I can't hear.
I think this is a hot topic because quite a few drafts working on this one, right? So this one looks like for the infinity matrix, looks like it's for unreachable, right? Also is used for aging out. For some LSA reach to max age, that we also consider this one is a one parameter for age out, right? Also
Aging out is done differently. It's not. I mean,
also this is the metric. So if some link metric or whatever metric is close to this value, how do you handle this case? Is considered also on infinity unreachable? Some big metric, I mean.
Yeah. So I'm not sure I understand. So you're saying, how do we distinguish this between the aging out of the LSA?
No. So in the aging out, I think in the RFC,
RFC says that you can use max metric or LS infinity as an alternative for max age. But the metric itself doesn't age out the LSA.
Yeah, I know. That's considered one parameter for age out in the RFC. If we check that one, another thing is for the Lincoln metric. For metric is close to infinity. How do you handle this case? Is reachable, but the metric is very big. It's close to infinity. So you consider is also unreachable or reachable?
Well, you can't do it, right? Because the spec says any metric is a valid metric and LS infinity has a special meaning. I don't think we want to define a new value of a metric for this.
So I think I consider those are different solutions. So this one you claim is backward compatible. I think the other solution can also make backward compatible, but I don't know. That's depends on the author.
Thanks, Wemo. Tony, you're up. Yeah, you've got proxy in the queue.
Tony P. Juniper, jumping into the slot. So as metaframe, we shouldn't forget that this is inflicted upon us by technologies that were, fashionable, but forgot that OAM is part of a, decently run network. And we're solving it in arguably the wrong protocol. Of all the better ideas to go about this thing, this is by far the best one, right? So it has a validity. Okay. What my comment is, I would not put it on the standards track because this fundamentally doesn't scale. We all know that, right?
No,
use that stuff as in the right amount as a spice can solve a problem with the technology without running a lot of machinery. We put it on the standards track. Everybody and our customers and their dogs will demand for the stuff to be implemented, and they will feel that this thing is something that should be rolling. And before we know, we have to start the large scale in deployment. So I would keep it on informational as something that you have in your toolbox and you pull out. And if you use it correctly, it's not a bad mechanism. I would not signal that. I think it's completely superfluous. I mean, the beauty of this thing is that actually without signaling it will work. You can mix it and it will work fine. If we really, really push for the standards track, I think the operational concern is something that will be steering straight into your face. Like a really big operational section saying like you're peeling off stickers and you'll get hurt, most likely. Or maybe a separate operational document, but this will get lost, right? So that's kind of my meta comment. But still, from all the stuff sloshing around, by far the best thing if you want to solve in the protocol, and no signaling. I mean, that will just ramp up complexity to the max. Yeah.
All right,
Thanks,
so
Pete.
I agree with everything you said, even with the best of the bad things, but you know, we have to solve the problem in a certain way. So in terms of the standard track, I wish we can keep it informational. The only thing is that we are changing the ABR behavior in terms of propagation. There is some normative language there. I don't know if we can do that in the information.
Okay,
if we can, I'm all for it.
We do have a lot of
interesting
slop
thing.
in our agenda, but we're going to have to
This is
move
very
on.
subtle. We do not change ABR behavior. And I explain why. Because the only thing we mandate is the behavior of nodes on the wire. That's it. The whole IETF interoperability means that we define the observable behavior on the wire. As long as you comply to the specs. Everything else is kind of over specification.
Works for me.
Right?
Works for me.
Because we say about like how you compute, okay, SPF computation is like where it starts to get delicate. But all the redistribution, summarization, and so on, right? We've write documents about it, tell people how to implement it, but we really over specifying. As long as this thing does on the wire something that complies to the protocol specs format, you are conformant.
Look, I leave that to the working group to decide. There is some language in the existing specs about when you propagate prefixes between the levels or areas, and that talks about reachability. Look, I really would like to keep this informational, to be honest.
Yeah.
This is the only thing. If we can do this with information track, I'm all for it. I'm with you on this.
Okay, I think we're in violent agreement, and
Yes.
I made my point.
Or we could go experimental too. I mean, I do think, speaking as working group chair, we could make an experimental because as well, and because we do specify the ABR behavior in both ISIs and OSPF.
I'm agnostic, right? I just know what happens once the stuff moves on the standards, how the RFPs start to fill in with the stuff, right? Okay, thanks.
Thanks, Tony. Aiden, you're up next, but can you please go quick? We've got two other people before we got to cut the queue.
One additional question. So if the ABR just want to recall one specific prefix, but not deliver the unreachable information, how do you do, and how do you differentiate your newly defined unreachability behavior? Okay.
Sorry, I didn't understand.
I
No, are you talking about the metrics still?
Yeah, I think there are already the usage of the LS infinity within network or in future. So if you define two or more meaning for it, I think there definitely will be exist the obscure scenario as the receiver cannot judge case. Okay.
So what I would propose, maybe if you have any particular scenarios in your mind, just please list them, put it on an email on the list,
thank you.
and we can go away.
All right, Shraddha, you're up.
Can you hear me?
Yes, we can.
Okay, so when we summarize a prefix, it loses a bunch of information, right? Bunch of details. So one is the unreachability information. Similarly, you also lose the metric information. So one of the very common techniques that is used to drain the traffic from nodes is to set the node to overload and then advertise high metric, which informs the other PE to remove that node and choose another PE to send the traffic. So this functionality is also lost when you summarize because you can no longer send the metric for this particular higher metric for this particular PE.
Correct.
So what I'm trying to say is there are more use cases which arise out of the summarization that today or in future will need to be solved, and we also need to look at how we are going to solve those when have a single mechanism to solve all these kind of use cases instead of looking at them one by one.
That's a fair comment. Do you see why we can't use this mechanism for the use case that you just mentioned?
Yeah, so there is a difference, right? A planned maintenance is different from, unreachability. If the node really goes down, you probably want to trigger BGP pick. But if it's a planned maintenance, all you want to do is in your BGP best path selection, you just want to cost out this particular PE, right? So there is a difference. It's not the same.
Okay, well, if you have any idea, I'm all for it. That's a generic solution. We are really trying to fix a particular use case. You're right. If you have something more generic that we can use, I'm all for it.
Yeah, and that was Tony P's point as well, right? It's like, it'd be nice if we could solve this kind of the right way, right? Instead of just, but
Well,
anyway.
What is the right way?
Yeah,
There are many other ways.
Yeah.
Right.
All right, thank you, Shraddha. David, you're up. And Dan, I'm sorry, but I forgot to lock the queue. David's going to be the last comment.
David Lamparter. It's a pretty minor detail, but the behavior for the very high metrics is not quite the same in ISIS and OSPF. And I think the draft is accidentally changing existing behavior for ISIS for those high metrics. I think it might be better to...
No,
really?
No. If you go over the draft, there are sections from the both protocol specification.
Okay, great.
You are talking about the link metrics? That's right. But prefix metrics, the unreachability is defined in both protocols.
Thank you, everybody. Next up. Yes, it's still you. We just read. We do have a little bit of slop in our time, but we were starting to go on beyond even the slop. No, it's okay. You can take your time. You can take the slotted time.
All right, so this is just a very quick update on the reverse affinity on behalf of the co-authors. So next slide. So this has been presented in the interim. I guess during that time, I actually got the feeling that people kind of acknowledge that it's the useful use case that we are trying to solve. It's a very simple extension, adding the exclude, include, and include all reverse affinity sub-TLV to the FAT, and then accordingly the rules in the calculation, where we are basically doing exactly the same thing as we do with the regular affinities in the forwarding direction. Next slide. So I haven't received any other comments, or we haven't received any other comments on the list. They're always welcome. For me, this is a very straightforward extension, and we can just adopt it and work on it. I really don't see why we need to wait. There is actually an implementation on it, just do it. That's all, so I saved some time.
Yeah. Yeah, maybe I was overly worried. All right. Thanks, Peter. It doesn't look like anybody's getting in the queue. So yeah, please read the document, and I guess we'll have to decide if we do an adoption call or not.
Right. We got about
three before the.
No, three or four.
Yeah.
Speaking as working group chair, I know we have some, I know a lot of you were in the interim that we had between IETF 114 and 115. We have some adoption calls from that, from those drafts as well. So we got some adoption calls queued up.
Okay, can everyone hear me?
Yes.
Yes, from remote. Okay, hello everyone. My name is Zhuoyue from Huawei, and my topic will be loop detection for imported routes. Next, please. Uh, this is a syllabus for today's presentation. Okay, next slide. Next, please. Yeah. Um, as dynamic routing protocols, ISS and OSPF are widely used on live networks. Multi-route import between IGP instance is often involved in networking solutions. However, uh, with strict routing policy and always needed for this scenario, for example, the figure show in the slide, when multi-route import happens among more than two IGP instances, shown as the picture, there will be multiple routers um, as router C and router G. They will import the same prefix 1.1.1, for example, from two different IGP instances, which is ESIS1 and ESIS3. They both import the prefix to the ASS to precise. Um, both these two prefixes are advertised by root C and root G as an external prefix. They are share the same priority, and in this scenario, what we need to do is configure right routing policy in these ABRs. Otherwise, human almost make this when the routing policy configured wrong, the routing loop may occur and cause critical network problems. So we make this draft to find a way help IGP instance to find out whether a prefix it will import from other instance is already being advertised or redistributed by itself. Next slide, please. Um, if the IGP instance could recognize the route has already been redistributed by itself, when it try to import a route from others, the route will knows that there might be routing loops because the instance report the prefix again. And therefore, we propose a new sub-TLVs in the draft to support advertise IP version 4 and IP version 6 prefix extend attribute flags and a list of source root ID of the routers which has redistributed the prefix. Next slide. Shown as the slide, uh, we name this sub-TLV as prefix redistribute list sub-TLV, and it will be advertised as an optional sub-TLV of TLVs 135 to 35 to 36 and to 37 in ISS LSP. Shown as the TLV feature, um, the prefix, the type value of this sub-TLV will be 10, and the length of the type field and the length field are both 1 byte. The value field start with 1 byte prefix extend attribute flags. The first bit of the flags is S flag, and the second bit of the flag is R flag. All other bits are reserved for future use. Let me explain how the flag use. For a given sub-TLV in one ISS LSP, when the S flag is set, the prefix has been redistributed by the router which generated the LSP. That's the meaning. When the R flag is set, the prefix has been redistributed by other routers other than the router which generated the LSP. And after one byte flag, a list of root ID will be presented. Each root ID will be 6 byte ISS system ID. And all the router ID in the list represent a router which has imported and re-advertised the prefix. Um, That's all the content about the sub-TLV. And just before the LSR session, we received some comments. Um, um, they ask for the difference between the draft and the RFC 7794. We make some explain and we will address it here. We received some comments say that root important not only between ISS instance but also between ISS and OSPF. So the root ID here we defined as is system ID for 6 bits, which may not be perfect. Um, it may be changed for further extensions uh, to be more extendable. It can be any it can be the root ID from any protocol to solve much more scenario problems. Next, next slide, please. And also, we do not aid OSPF session in the draft. So the further plan will be the OSPF prefix redistribute list up till we will still need to be discussed how the TLB will be work. So that's all for my sharing. Thank you. Any
Thank you,
questions?
Tony. Yeah, Tony P is up.
Tony P. Juniper, so I can make it one sentence. We should very most definitely not do it. And if you want 2 more minutes, then I can give some clue dispensing. Otherwise, it's the comments like kill it as quick as possible. Yeah.
That was also expressed by Les on the list.
Okay,
just to
so
throw that out
we do
there.
2 minutes clue dispensing or good
Yeah,
enough?
if we do have 2 minutes to dispense.
So it is exceedingly bad network design in 99.9% of the cases. So if you need those prefixes to be around, you build a hierarchical IGP. And if you run out of hierarchical IGP, then in 99.9% of the cases, you should go and segment it via BGP. Okay. Yes, you should. Well, otherwise you start to build a distance vector protocol on top of this whole thing. And if IDR lets us do that, and then we start to invent, the attributes on the whole thing, and we basically start to carry the whole distance vector protocols around. And the case, there are only 2. No, this is really just one case when you run out of hierarchy, which happens in 0.01 even 8% of the cases. Okay. So.
And isn't it, am I wrong in saying that in that 0.01 case, you also have to configure your routers wrong?
Right.
So
correct.
this is just protecting operators from misconfiguring in 0.001% of the cases.
If you have a customer that ends up in this case, he better be extremely clueful. And then managing those policies, the least of your problems. So we are piling an enormous amount of complexity into the protocol, okay, which will have a very hard time to standardize, and it will be almost impossible to deploy, right? Because there's no way any of the stuff will be backwards compatible with old routers, and buggy versions will lead us down the BGP path, right? 20 years of trying to maneuver the whole distance vector, or actually, we'll drag the attributes around with us on top very quickly. Okay.
All right, thanks, Tony. AC, you're up next.
Speaking as working group member, this I agree with everything Tony said, and I just wanted to say that this the way the draft is written, it doesn't, routers don't work that way. You distribute routes through the RIV, and only the active routes get leaked between protocols. You don't have any direct instance to instance that would be broken to do that. Right now, I have had networks, not with not with 3 instances in a row, but with 2 instances when we've had OSPF networks due to acquisition were combined, and at the boundaries there is already a tag. It's in all the Yang model. I don't think it's mainly a BGP. I guess it is in the protocols as well. It's in all the protocols. There's already a tag that's advertised, and what you do is you use that tag to keep the mutual redistribution working from redistributing routes that have come from one instance into another. That's commonly known. It works not only between protocols, it works between protocols of the same type. It works between all types of protocols and static routes or whatever that are re-advertised in IGP. So I would say kill this as soon as possible, and certainly don't waste time on the OSPF extensions.
You're right, but what we try to solve is when routing loop happens, we can use this subtlety to detect the loop and take some actions to solve. Of course, we have
tag in a route policy.
But when the route policy configured not correctly, it still will be routing loops in the network.
Okay, thank you. Peter, you're up now.
Peter Pshenak, Cisco. So I'm just going to probably repeat. Redistribution happens, Tony. I wish it doesn't, but it does when people use it. I agree, but it does happen. So the problem is valid, but the solutions are there. They are existing. We have mechanics and protocols and on implementations. I don't think we need this draft. Thank you.
Thank you, Peter. That I think was also AC's point with the admin tags. Right. Okay. Is that it in the queue? Okay, thank you. Thank you, Zhao.
Okay, thank you.
Oh, you're very quiet. Leanne?
Okay, I can see it.
Much better now.
Okay, thank you. Hi, this is Leanne from China Mobile. I'm going to talking about the topic of advertising unreachable links in OSPF. Next, please. This is the 0.0 version of the draft, but the requirement has been discussed in the interim meeting in September. And as discussed in the interim meeting, there are some requirements to advertise unreachable links in the base algorithm of IGP to avoid building the normal shortest path tree. And for OSPF, the current existing mechanisms cannot meet this requirement. So based on this, we propose a new draft to elaborate this problem and the solution. Next, please.
Oops, sorry. Did you want that one?
Okay. This is the initial scenario of the problem. Since it's not only related with the flex algo, but here is just a typical example when the flex algo is applied to the network slice solution. From this topology, based on the default algorithm, the right links which is the sub-interface with dedicated bandwidth resources. It is used by the Flex Algo 128 and it's newly deployed for network slice. It is expected that only the particular flows which is belongs to the slice are transmitted on read links. However, from the picture, can see all links are contained in the default topology used by normal SPF calculation, and the flows of best effort service will be steered into the read links. Our goal of this draft is to exclude the newly deployed links from the base algorithm to avoid it changing the existing traffic forwarding. Next, please. This is the current situation of the maximum link metric in OSPF. The RFC 1247 defines that it is unreachable, but when the RFC 1583 updates, that is reachable. And from the current implementation of most devices, and they are based on the version of the RFC 2328, and a link with the maximum link metric is treated as the reachable. So to resolve this problem, extensions or updates for OSPF is required. Next, please. This draft proposed the two solutions for the problem. This is the first solution, solution A. It leverages the existing mechanism as much as possible, treat the maximum link metric as unreachable. Using this solution, the backward compatibility should be guaranteed, or else there will be routing loops. For example, the metric for each link is shown as the following figures, and the router A treat the link D2F as reachable, but the router B treated as unreachable. So there will be routing loop between A and B. Next, please. To avoid the loop, all the routers should negotiate functional capabilities. So a new bit is proposed based on the current mechanism, which is described in the RFC 7770. So the new bit, we just call it M, the M bit. It is newly added to indicate that the router support the new feature, and the maximum link metric should be treated as unreachable during normal SPF computations. If there is any router does not support it, so all the routers should recalculate the SPF to treat the maximum link metric as reachable. This describes the maximum link metric can be extended to the following TLV or LLCs. The router LC and the OSPLv2 extended link TLV, and the router link TLV of OSPLv3 router LC. Next, please. This shows the second solution, solution B. Instead of changing the meaning of the maximum link metric, a new unreachable link flag is proposed. It is advertised in OSPLv2 extended link TLV of extended link opaque LSA, which is defined in RFC 7684. And also the OSPLv3 router link TLV of e-router LSA, which is defined in RFC 8362. Also, the new unreachable link flag, if it is used, the backward compatibility should be considered, and it is similar with the previous solution. Okay, next, please. Oh, that's all. We would like to hear your questions or comments. Thank you.
Okay, thanks. AC, you're in the queue.
Yes. Speaking as working group member, have you?
You got to turn the mic. No, just face it towards you. Yeah.
Speaking as working group member, I thought about this, and I guess either solution would work as long as we have the capability and don't use it. It would be nice if we use the capability just to use the same thing that ISIS uses with the MAX network. I know if you didn't have the capability, you can't just start using it because many implementations use the reference bandwidth to compute the network. So if there's an outlier link that's very slow, it's going to have max metric. And all of a sudden these would, if we change this without the capability, all of a sudden these links would start. Actually, that's a reason not to use it even if they support it, because these links are going to be auto-configured to max metric, just the way it would. Again, it was done for convenience, but anyway, I think if we were to use max metric, we need to put a note in there that you should not ever use max metric when using reference bandwidth. That's all I was going to say. I'll put it to the list too. I can see some people not understanding. There wasn't enough context in my comment unless you're really familiar with OSPF configuration.
Okay, thanks, AC. John, you're up.
As a working group participant, yeah, I mean, I got that. It's like if you use max metric for this signaling, then if you actually want to signal a metric, it has to be topped out at max metric -1, which I think basically it's like the two solutions, either one would work. It's sort of unfortunate we have to go there. But you know, given that there's one solution that requires you to treat max metric in this new and special way, and the other solution just creates a distinguished don't use this link, and it doesn't try to reuse an existing field, you might as well go with the one that has fewer knock-on effects. So meeting solution number 2 seems like less of a pain to me. Thank you.
Thanks, John. Katan?
So I had a comment about the capability part. I would suggest the authors to look at RFC, the OSPF host bit RFC. I think it's 8770 on how to handle this kind of things which affect the SPF. And I think the draft needs work in that direction. RFC 8770. Yeah, thanks.
Thanks. Shraddha?
Okay, thank you. I will see it.
Hello, can you hear me?
Yes.
I was just thinking there could be alternate ways that can be done locally, right? I mean, because you don't want to use it in the default topology, you advertise
Yeah,
maximum
yes.
metric for in the default topology. So the traffic would always use alternate paths which are lower metric. And if there are no alternate paths, traffic would still get steered to this node through this link, and which, I mean, you can have local rules on that router to drop the traffic, because if there are no other paths, you simply want to drop, right? You strictly don't want to allow other traffic on this link. I don't know why you didn't think that as a solution.
Because I know your question, and I try to explain it. Because from our scenario, the new link, the link of the sub interface is newly added. So if the cost is much more smaller than the default topology, the traffic will be steered to this sub interface. But this is not what we want.
Yeah, I get your case. I mean, the flex algo can use a different metric type, right? Which will have a lower metric for these links, and then traffic will get the flex algo traffic would get steered on these links. Whereas the default you can default will use IGP metric, right? You keep IGP metric high metric on these.
Yes,
So
there are three calculated tabs for flex algo, I know, but if we use other metric tabs, all the links should be management for this. So
yeah,
with the
which
IT cost, it's much more easier for the implementation, I think.
yeah, I mean I mean it's equally difficult all your vendors to implement this and upgrade all the routers, and only then you can use this feature, right? It seems much more easier. You can just use a different metric type. No, that's just my thought. I do see where you're coming from. Thank you.
Okay,
All right,
thank you.
thanks, Shraddha.
We can discuss it because we have solved this problem before.
All right, thanks, Leon.
Yeah, thank you.
All right, I think we're on our last presentation.
Flow spec, right?
Yes, flow spec.
Okay, hello everyone. I'm from Changzhou. Hello, good morning. And today I will give introduction about the OSPF and the EZ's extension for the flow spec. Next slide, please. Okay, why we extension IGP for the flow spec? Flow spec is, as you know, is used for the traffic filter and DDoS and DDoS like this to protect the network. Normally, BGP is used to disseminate the flow spec rules and distribute the flow spec rules between the PE but for some in some scenario, the attacker is do the attack to at the CE. So if we close to the source, better the protection and block the attack traffic as earlier as possible, it's better. Okay, next. And another scenario is in some network, there is no BGP deployed. So just the IGP is used, like the campus network. So, but in this network, the attacker is also exist. So IGP is need to distribute the flow spec rules to the other routers and to protect the network. Okay, next. And also in this the scenario, the traffic analyzer is at the remote CE, and but the attacker is in current CE. So if we use BGP, we need to just can distribute the flow spec rules to the PE2, but the CE2 can't get the information. So if we use the IGP, the rules can distribute to the CE2, and we can block the attacker at the CE2. Okay, So that's why we extension the IGP of the OS flag cycle. Okay, next. So we expanding the OSPF and EZs for the flow spec. For EZs, we define a new TLV that's the flow spec reachability TLV, and this TLV have the format of the main TLV of the EZs, and we added a flag L is to identify the control leaking between the levels of this TLV, and this TLV have two sub TLV. The sub TLV is the flow spec filter sub TLV and the flow spec action sub TLV. These two TLVs is the same as defined in RFC 557F5. Okay, next. And for OSPF V2 and V3 is different. For OSPF2, we use the type 10 or type 11 LC for optical LC for this for carrier this TLV, and this TLV also have two sub TLVs. One is the flow spec filter, and one is the flow spec action. Also the same as defined in 557.75. And also as the route information, I will say we add the flow spec capability TLV to advance the capability of the router. Okay, next. So also V3, we will define a new LC to carry the flow spec TLV. And this TLV also have two sub TLV of filter spec filter and flow spec action, and the same as the FC 5575. And also the flash capability advancement bit we used. And for OSPF, maybe we can transport this information use the OSGT like this. Okay, that's all I have introduced and comments.
Okay, hi. So this is coming back. It was previously presented, I think, in ISIS and OSPF separately.
Yes, this is the OSPF work group draft before, and currently we are reactive at the LSR.
So this will be me speaking as working group member. This is, you're configuring your firewalls with your IGP. I mean, this is just not something that we should be using our routing protocol for. You know, you have a traffic analyzer. It should be using your network management tools to configure your routers, right? I mean, I understand that BGP is a dump truck and everything goes in it. And I also understand there might actually be a reason for it, because, you know, you might want to be giving this information to another administrative domain, but that's not the case here. We're talking IGPs, it's the same administrative domain. Yeah, so there's no point of that. You did bring up this CE1 to CE2 case, but that's insane, right? I mean, no provider is, you don't have Microsoft configuring Google's routers, right? It's just not going to happen. Yeah, or let me rephrase it then. Let's say,
Are you speaking as an individual or Microsoft?
Yeah. I should have just picked two better competitors, but yeah. Anyway, that's my comment as a working group member. I'll let some other folks talk now. Les?
Okay, but in campus, I think we can use this.
Yeah, so I agree with Chris. I think this does not belong in the IGPs. I think from a presentation point of view, it was very nice that we started with the OSPF generalized transport and ended with this flow spec, because if you are going to put this in the IGP at all, the generalized transport, or in the case of ISIS, GenApp would be the only way to do it. I'm not real enthusiastic about that either, but this certainly doesn't belong in the routing instance of the IGPs. Thanks.
Okay.
Thanks, Les. Jeff.
Jeff Haas. So I agree with the other discussion points about this probably belongs in something like the generalized transport, just to get it out of the IGP. I've looked at the encodings. I spend a very large amount of time working through FlowSpec, both in IDR and in Juniper's implementation. Your encodings are clean. This would work. The one point I ask you to consider, have further discussion specifically in the IGP context, aside from the use cases, is are you comfortable with very large FlowSpec filters going into an LSA? Because BGP can fit 4K inside of a PDU. We have seen field experience with filters that are in the order of 2 to 3K worth of size just for the match statistics. My impression is that you really don't want to put 2 to 3K worth of state into an LSA. That gets a little cranky.
Okay.
Okay, thanks, Jeff. AC.
AC Lynn was speaking as a working group member. The one thing I'm wondering, let's say we were to do this in GenApp and generalized transport, and we were to do this, could we just get away with not having to redefine the flow spec and to just use the VGP definitions rather than you cannot? Okay, I was just.
Jeff Haas again. So the document you have is very close to the BGP flow spec. That's great. You're actually taking some of the lessons. I have to look at the encodings, make sure that PCEP did when they decided to do something very similar and use flow spec encoding rules to carry flow specs into PCEP. There are bugs in the existing RFC for flow spec for extensibility. I think you may have avoided it by using something close to PCEP. I have to double check. I urge you to pay attention to the FlowSpec v2 work that's going to be happening in IDR. We're picking up heavy steam right now because that's going to change a number of things about how FlowSpec works. So you're chasing to try to get up to what FlowSpec currently can do rather than potentially where it should be going. But in terms of encoding, your flexibility is about where it needs to be. The changes to get to safety that PCEP has, if you haven't done them already, is very small.
John, you're up.
Just very briefly, thank you, Jeff, for also mentioning the PCEP option if you don't want to put this into the IGP.
Great. Okay, well, we didn't run over.
Okay.
Yeah, thank you. Let's talk about, I'll just mention, we did have an item that we were thinking about putting on here, which was the multi-part TLB discussions that have been going on. And Tony and Les both have I think they might have worked on some slides, but I think we're going to do an interim on that. We're going to also, I'd like to get more solutions based. I mean, just personally as a working group member, I've got an idea of what we should do. And me and AC were just talking on the side, and I'd like to get that out on a list and then, and then have a meeting to sort of finalize the decision on what we should do there. I don't want to be unfair and present my position since we didn't give the other people.
Speaking as working group member, yeah, I'm really hesitant since I much more have much more experience with OSPF than ISIS to inject how I think it should work. In the meantime, we have found there's lots more deployed implementations than we originally. I mean, I've talked to other other people, and they
Yeah, I've heard as well. There's at least 2 different vendors that have done this. Have you heard more than that?
I have, yes.
Okay. All right. So it would have been nice. Like, I was really hoping that those vendors would have spoken up on the list. If you still could, like, I mean, this isn't a secret, right? We're talking about making the internet work, right? It'd be nice to know who's implemented network breaking functionality. You know, and you wouldn't be the first, so I don't know. Maybe you don't want to admit it. Anyway, that's it. Unless anybody else has some an open topic they want to discuss, we do have a few minutes left. Okay, well, we'll see you in the interim then. Thank you.
That was interesting. You know, as far as non-complex algorithm, she was thinking, there's not worried about everybody in the domain having to support this. There's very little chance. That's true.
So original idea was to actually work in the domain because you want to propagate the filters for DDoS.
Exactly. No, no.
Microsoft and so on.
I mean, it's like
the most effective routes in graph.
But that's what you use BGP to talk between administrative domains.
BGP is running, not always. BGP is running. OSPF is running for peace.
No, but Google and is not talking to Microsoft in OSPF, right?
No,
Ever.
For VPN custom, let's say, prevent generating DDoS. This is not about Microsoft